Hello, okay na mo diha?
Okay, that's
Sige diha,
okay, that's
ako na lang gikuha ang URL sa ako kuan YouTube live.
delete.
Para mapanin nyo sa uban na dili maka sarabaning gina ang correction. Okay, good afternoon everyone.
Good afternoon, sir.
Good
Good afternoon, sir.
Okay, sa katong maglisod og connect sa Microsoft Teams, ako gibutang ang link dito sa ato group chat. Dito naka YouTube live. Kung maglisod mo connect, okay, pakita palihog ko kita na lang atong YouTube live. Okay? All right, so good afternoon everyone. So how is your day?
It was good, sir.
All right. So pasensya wag gid ko makahatag ninyo sa recording pero may lanas po siguro nga wa ko mag-recording kay base maglisod gyapon mo sabot kung maghatag lang kog recording mas mayo na siguro i-discuss ko na lang. Okay. So for this afternoon we will discuss circular motion and the equations of simple harmonic motion. So there is sa ato ipakita karon nga sample sa circular motion. We will see how the different equations in simple harmonic motion are are derived.
Good morning. Circular motion, when viewed from the side, is simple harmonic motion.
What?
Yeah.
Okay, okay, fine. All right, so to discuss this circular motion and its relevance to simple harmonic motion, please watch this short video clip.
In physics.
Circular motion, when viewed from the side, is simple harmonic motion. Let's take a look at this turntable of a record player. I've placed a yellow marker cap on it so we can observe the circular motion of the cap. Does everybody see that the cap is moving in circular motion?
Yeah.
Yep. Yeah.
Okay, now let me add a side view of the turntable and yellow marker cap. Do you see how the cap appears to move in simple harmonic motion?
Yeah.
No.
Okay, so then I will add a vertical mass spring system moving in simple harmonic motion. Now do you see how the cap appears to move in simple harmonic motion?
Yeah, sure.
Yep.
In fact, we can also add a front view of the turntable and yellow marker cap. And we can also add a pendulum moving in simple harmonic motion. Do you now see how the cap, when viewed from the side, moves in simple harmonic motion, just like a mass spring system and a pendulum?
I saw it from the start.
Yeah, there's a lot going on in this.
Okay, sure. So there is a lot going on. So I will simplify it by removing everything but the turntable and yellow marker cap. Now I will add a dot that is motion tracked to the top of the cap. And I will isolate the motion of the dot so it is only moving in the Y direction. This dot is now moving just like the side view of the cap. In other words, this dot is moving in simple harmonic motion. And watch the path it creates if we look at where the dot is located as a function of time. Does anybody recognize the shape of that curve?
Oh, that is a sine curve.
Actually, I think it's a cosine curve. Actually, it could be either one. Sine and cosine are just shifted along the horizontal axis relative to one another. Right, Mr. P?
Yes, this could be a sine or a cosine curve. It just depends on where it starts along the horizontal axis. So remember, simple harmonic motion and circular motion are related because circular motion, when viewed from the side, is simple harmonic motion. Thank you very much for learning with me today. I enjoyed learning with you.
So okay, sa inyo nakita sa short video clip, how is circular motion and simple harmonic motion related? Okay, people. So how is circular motion and simple harmonic motion related? Or what is the relevance of circular motion to simple harmonic motion? Hi, people of the Republic of the Philippines. What are your responses? Ah?
No, actually,
Okay, so unsa may relevance adtong circular motion sa simple harmonic motion?
linear ang
Di ba katong turntable gibutangan og yellow nga cup. So as the turntable rotates, the cup also rotates. Di ba?
yes, sir.
Kunya kung imo siya kitaon
Sir.
side view. Kunya kung kitaon nimo siya side view, how do you relate the motion of the cup, of the yellow cup? So unsa man ang motion? Describe the motion of the yellow cup if you are going to view the turntable sideways.
Linear, yes, sir.
Oh yes, the motion is linear. But how about the manner of the motion?
Light.
Ah? Unsa man po ang motion? How do you describe the motion? Ah?
Ni oscillate, sir.
At unsa siya mo?
Ni oscillate, sir.
Yes, okay. It oscillates. So kung kitaon nimo siya inside view, so katong cup mura po siya og mo-oscillate. So it means that it moves in a periodic motion. So the cup moves back and forth. So mura gyapon siya og simple harmonic motion. All right. So it is that relationship between circular motion and simple harmonic motion that some were able to derive the equations for simple harmonic motion out of circular motion. Right. So you are seeing here in your slide, okay, we have here an illustration. So this is a top view of a horizontal disc. Right. Saan ba tong pointer? Okay. Muna siyang ato horizontal disc. And then it has a radius. Okay, ang radius niya okay, we denote the radius as radius A. So ang radius A, mo na siya ang the length from the outer rim of the circle to the midpoint of the circle. So this so this horizontal disc rotates with a constant angular speed v. Okay, kini nga kuan, kini nga saraba ni wala ko. Saraba, how do I describe this? Okay, horizon. Okay, so this disc na ay kwan diri na ay ball. Okay, this is point Q. So this ball on the rotating turntable is denoted as Q. So magsige tuyok ang turntable at a constant angular speed V. So Q will project a shadow on the screen. So magsigig dagan ang Q, magsigig dagan ang kining P o kining shadow sa ball. So the shadow of ball Q is denoted as P. So mutuyok ang Q, ang P pod or the shadow of the ball moves back and forth or oscillates. Then ang ato point of origin is point O. So if we are to compare this with that of a spring system, so kining O mo ni siyang ato point of equilibrium. So nakainom mo last time kato ako gi-discuss ang katong spring system gani katong the point where the spring is neither compressed nor stretched, di ba mo? Kung asa to located ang mass adto, mo to siya ang point O. So dire we also try to resemble the motion of a spring with the shadow of Q. Alright, unsa man pud ning A nga naa diri sa shadow? Okay, different na siya diri sa A diri kining A nga naa diri ha. Okay, kining A nga naa diri, kining shadow is different from the A here, which is the radius of the circle, pero they are of the same measurement. Okay nga naman. So kung mutuyok ning Q, okay, mutuyok ni siya ang Q. Alright, let us say for example, naa diri nga point ang kining Q. So asa man located karon si Q? Okay, naa diri dapita. Right, naa diri dapita. So kini diri dapita mao ni siya ang iya maximum nga displacement if we will try to compare this to a spring mass system. So this is the amplitude of the system, which is equal to the radius of this turntable. So this is equal to radius A of this turntable. Okay, am I clear here? Nakasabot pa sa hugi pang istorya?
Yes, sir.
Yes, sir. Yes, sir.
Right. So balik ko na ako. So the ball moves in uniform circular motion. So kining Q will cast a horizontal shadow on the screen, which is point P. So as Q rotates or as Q rotates, P also moves like that of a spring mass system. So this shadow oscillates. So therefore, ang movement aning shadow is simple harmonic motion. So therefore, the circular motion of this turntable is simple harmonic motion or the projection of the uniform circular motion into a screen. Right? So now let's discuss the different derivations. Right? So, mo na siya. Okay, the ball, okay, ball Q moves in a uniform circular motion. And it casts a shadow on the screen, which we denote here as point P. So point P will move back and forth on the x-axis here, as shown. So it moves back and forth in simple harmonic motion. And then, okay, kini diri nga point dire, kini ato center sa circle is origin O. And then, the radius of the circle is A. So, magsigig tuyok ang Q. Okay, magsigig tuyok ang Q. Q will project a shadow on the screen, which is P, and will move back and forth in simple harmonic motion. So, the displacement of P here from its point of origin, right? So the displacement of P, the shadow from the point of origin O, can be measured by this equation. Kining nakita ninyo sa screen. Okay, the displacement is measured by, okay, x, which is equals to A, or the radius of the circle, multiplied by cosine theta. So nagdiin man ta nagkuha aning cosine theta. Okay, so we derive cosine theta, okay, from the cosine of the angle here. Right. And then asa man ta nagkuha sa A? Okay, gikuha natong A kining radius sa circle. So, if we can determine the angle here, and the radius of the circle, then we can compute for the displacement of P, which is equals to x. So x, or the displacement of P, is equals to the radius of the circle multiplied by the cosine of the angle here. So what does this reminds you? So this reminds you of, okay, unsa nga discipline sa unsa nga math discipline? Ah?
Trigonometry.
Okay. So, ang science of math, hindi na magbuwag. Okay, alam mo kabalaka, kay ko lang ni, ako lang ipakita sa inyo ang derivation. Okay, dili ta mo pasulbo ng ingunani. Alright. Alright, and then, okay, so this is the displacement of point P, and then, asan na ba to? So kung magsiginig tuyok, so magsiginig tuyok ang Q, as I have said, it will cast a shadow on the screen, which is point P. And kung unsa kapaspas, okay, kung unsa kapaspas ang tuyok ni Q, mo pod kapaspas ang horizontal movement sa point P, or the shadow of Q. Right? So the acceleration of P, okay, the acceleration of P is equal to the x component, or x component of the acceleration of Q. Right. Okay, remember, ang motion ni Q is in uniform circular motion. Alright. So because Q is in uniform circular motion, its acceleration vector, okay, AQ, or AQ is always directed towards, okay, this point here, or this point O. So the magnitude of the acceleration of Q is given by, okay, makita ninyo diri nga equation. Right. So the magnitude of the acceleration of Q is given by the angular speed or the square. Okay, square of the angular speed multiplied by the radius of the circle. Okay. Okay, saan na ba to? Alright. So, diri nga slide, ato gikuan diri ang equation in which we derive the acceleration of Q. Alright. In this slide, yun sa nato pagkuha ang speed sa sarapan ni kining shadow, kini siyang P. So the equation that you are seeing on the slide shows the equation for the x component of AQ, or this point here, this point P. So the acceleration in the x-axis of this point is equal to acceleration of Q multiplied by cosine theta. So we multiply the magnitude of the acceleration of this point here multiplied by the cosine of the angle here. Okay. And from there, so we combine these two different equation. Okay, kini siya, kini nga equation. So this is the equation for in determining the displacement of the shadow P, where the displacement of shadow P is equals to x is equals to the radius of the circle multiplied by the cosine of this angle. And the acceleration of this point Q is equals to the square of the angular speed multiplied by the radius of the circle. All right. So if we are to combine these two equations, so what we will get is that the acceleration, okay, the acceleration of, what is this? The acceleration of this point here, point P, is equals to the acceleration of Q multiplied by the cosine of the angle. So, okay. So, if we write this equation here, okay, this equation, if we rewrite that here, so we'll get the acceleration in the x-axis of point P is equals to the acceleration of Q multiplied by cosine theta, okay, which is equals to the angular speed, the square of the angular speed multiplied by the radius of the circle multiplied by cosine theta. Okay. Di ba kining AQ? Okay, di ba kining AQ mao man ni siya ang iya equation? Kita araw. Okay, kita na to sa to previous slide. Di ba na mao no? Okay, AQ is equals to angular speed, the square of the angular speed multiplied by the radius of the circle. Okay, so mo ni siya dire. Okay, AQ multiplied by cosine theta, or is equals to angular speed, the square of angular speed multiplied by the radius of the circle multiplied by cosine theta. Okay, nga naman to ang negative ning nakabutang dire. Pamo may buong anong negative? Anyone? Okay, anyone? Wala mo may buong anong negative ang nakabutang dire? Right, people of the Republic of the Philippines. Okay, nganong negative man? Okay, negative siya tungod kay okay, pagtuyok sa pagtuyok aning Q, ang iya direction is towards the left man. So if you move towards the left, ngadto man na okay, ang negative naman na ang saraban. You are moving towards the negative direction. Whereas kung if you are moving towards the right, okay, you are moving towards the positive direction. So there it is indicated that the movement or the angular speed of Q is towards the left. Okay. So if we are to simplify, the acceleration in the acceleration of the shadow in the x-axis, so we can rewrite this as a sub x is equals to the square of the angular speed multiplied by x. Okay, di man gikuha ang x. Okay, anyone? Okay, balik na dire. Okay. Di ara. Okay mo na siyang x, di ba? Nakita? Okay, nakita. Nakarelate. Ha?
Yes, sir. Katong
Okay.
answer determining of the shadow.
Okay. So karon gi-simplify nato ang equation. So we have a x is equals to the angular speed, the square of the angular speed. Okay, it is only indicated as negative because the point Q or the angular speed of point Q is moving towards the left man, and x is okay here. The radius of the circle multiplied by the cosine theta. Naka-screenshot?
Yes, sir.
All right. So the acceleration of point P, okay, the acceleration of point P is directly proportional to the displacement, okay, to the displacement x. Okay, so kung sa kapaspas, okay, kung sa kapaspas ang movement sa x, okay, it has an impact on the acceleration of this point P. So, gining point Q, o musunod po ang P. Alright, so the acceleration of point P is directly proportional to displacement x and always has the opposite sign. Okay, so these are the hallmarks of simple harmonic motion. Right. So we can rewrite the angular speed or the square of the angular speed as, okay, angular speed squared is equals to spring constant divided by the mass of the object. Or simplify this as angular speed is equals to the square root of spring constant divided by the mass. Right? So this is angular frequency for simple harmonic motion. Di ba na-discuss na naman ni siya, no? Last time, ato lang ni siya gibalik ron. So the angular frequency for simple harmonic motion, or the how do you pronounce this Greek letter? So this is a Greek letter. How do you call this? Is this, yes, omega? So this is Greek letter omega, small letter omega is equals to the square root of the spring constant or the restoring force divided by the mass of the object. So if we start oscillating a body in simple harmonic motion, so the value of the velocity or the speed is not ours to choose. So this value of B is predetermined by the values of the restoring force and the mass. Alright, okay, ato i-review lang. Kung sa to unit sa spring constant, unit Sa to unit sa spring constant? Anyone?
Rad.
Ang unit sa spring constant kato sa K. Ang kini ba ang unit sa K ba? Sa to siya Newton per meter ba to? Ha? Newton per meter ba to? Okay. So ang unit sa mass, unsa man? Unit sa mass. Ha? Unit sa mass. Ha? Kilogram. Manubag eh. Ang unit sa angular frequency.
Rad.
Rads per.
Second.
Okay, rads per second. Okay. So this is the different equation for frequency. So to discuss last time, okay, the equation in 1 over period man, no? So in angular frequency, we can write the equation as the frequency is equals to angular frequency divided by 2 pi, or frequency is also equal to 1 over 2 pi, the square root of the spring constant divided by the mass of the object. So for the period can be derived by dividing the frequency by 1 or 1 over frequency, which is also equals to 2 pi over angular frequency, or 2 pi multiplied by the square root of mass divided by the restoring force or spring constant. Here we have 2 questions. Okay, what would happen to the acceleration of the object if it has a larger mass? Okay, so kung bugat kayo ang object, how would you describe the force needed in order to accelerate the object? Anyone?
Mas need og ako nga force, sir.
Yes. So if the object has a very large mass, of course you will require a very large force in order to accelerate it. So tungod kay kinahanglan magkag larger mass, so what would happen to the acceleration? Kay tungod kay dako man ang iya mass. Okay, is it slow or very fast? Is it
Slow, sir.
right?
Slow.
Okay, so hinay ang iya acceleration
Slow.
tungod kay dako man kayo ang iya mass. But if you could apply a bigger force to that object, so it can accelerate the way you would have wanted it to be. Pero kay di man, so we consider the acceleration to be less. Right, second question. What would happen to the acceleration of the object if the spring is steeper? Kung gahi kayo ang spring, so how would you describe the acceleration? Kung gahi kayong spring. Okay, tungod kay gahi kayong spring, mo require na pud ka og dako kay nga force. Pero kung imo buhian ang spring, usa po ikuan, what will happen to the acceleration? Sige, ingon na ni, ikumpara na to. Okay, biraha ang humo kayo nga spring. You apply a bit of a force, then imo buhian. Okay, try to imagine the acceleration of the spring, and then try to imagine yourself pulling a spring which is very steep, kanang gahi kay nga spring, unya imo buhian. Unsa man pud kay reaction sa spring? So asa man diri ang paspas kayo magkuan, asa man kay diri paspas mo oscillate, ang humok o ang gahi nga spring?
Yan po, pagpaspas ang humok. paspas ang tubo kaysa sa gas.
Mas paspas mo accelerate kung gahi ang spring. So if the spring is stiffer, the acceleration will be greater. Okay, so try to remember these two things. If the object has a larger mass, acceleration is lesser. If the spring is stiffer, the acceleration of the object is greater. Okay, sample problem. Mag-sample problem dayon ta. Sige, paki-screenshot sa. Nakakuha na? Naka-screenshot na?
Mana, sir?
Okay, sige. Ah. Okay, makita ang kuan, makita ang ako whiteboard.
Yes, sir.
Yes, sir.
Naklaro.
Okay, so let us answer this sample problem. So sa letter A, unsa man ang gipangita sa letter A? Unsa ang gipangita?
Ang force constant key of the spring.
Okay, spring constant. So unsay equation sa spring constant?
Angular frequency.
Makita na ako para makapokus mo sa kuan. So unsay equation sa spring constant? Okay, equation sa spring constant. K is equals to
Equals to
X over F, sir.
K is equals to
X
F.
over F, sir.
F.
X over
F.
F. Mo ba na siya? Sakto ba? Ano ha? Ato kitaon ang katong kuan. Kx. So kung K ato kung taon. Okay, sa iyo pang inyo equation giatag. So sa isa tong equation.
Equals to X. Key equals to Fx over X.
Okay. Okay, so ato equation dire K is equals to F over X. Dakon ko lang para maklaro. Okay, K is equals to F over X. So, pila ang force as given in the problem? Okay, pila ang force?
Zero point, delay. Newton.
Ah,
0.0 Newton.
pila ang force?
6.0 Newton.
Okay. Okay, 6 Newton.
6.0 N.
Okay. Okay, pila man ang displacement?
0.030.
0.0 m.
Okay. 0.030 meter. Right. So, pila man ang spring constant? Okay, from that equation. So, 6 divided by 0. Okay, pila? Pila to
200.
constant?
200.
Okay, ayaw ko taga-eg magnitude lang, taga-eg pud kog unit. So, pila man ang ato spring constant?
200
200
N over m or mass.
Okay, spring constant is equals to 200 Newton per meter. So, mo na ning ato, okay, mo na yung ato K. Okay, naka-screenshot na.
Yes, sir.
So, letter B, ang gipangita karon is the angular frequency. Right. So, pad-on ko na ni ha. Okay, pad-on
Yes,
ko
sir.
na ni. Oops. So, unsa equation sa angular frequency?
Omega equals ang sani pangan ka ng paana
Square root?
square root, sir, square root as k over m.
Okay, square root of K over M. So, nana mo yung value sa K. Giso ni nato ganiya. And naabot
Yes, sir.
na yung value sa M given sa problem.
Yes,
Right.
sir.
So, okay, pilang ato K?
200
100
Newton
Newton
over
per meter divided by
0.50 kilogram.
0.50
kilogram.
kilogram. Right. So, pila?
20 rad per second.
Okay. So, our angular frequency is equals to 20
Rad per
radians per second. Naka-screenshot na?
Yes, sir. Tapos na, sir.
Okay, how about the frequency?
F over omega, then
F
Ang sa-
over, okay, frequency is equals to, sa equation?
Angular
Ah,
angular frequency over
angular frequency over,
2
pi.
okay, angular frequency over 2 pi. So, our angular frequency is
200
rads
Rad.
per second, okay, divided by 2
2 pi.
pi. So,
3.2 cycle or HZ.
hertz. So,
Hertz,
3.2,
Hertz are cycle
okay,
per
3.2 cycles per second or 3.2 hertz.
Yes, sir.
Okay, naka-screenshot na.
Yes, sir.
Okay, how about the period?
The
Okay,
period ay ang equation kay T over 1 over frequency.
okay, so 1 over 3.2 hertz.
2 or hertz. So equals to 0.31 seconds.
Okay, 0.31 seconds. Okay. Okay, kini siya. Sa balay na ninyo answeran. Pero napakayo magpadayon pa ta discussion. Okay, sa balay na lang na ninyo answeran. Okay, dali naman lang kayo na, di ba?
Okay, sir.
Sige, paki-screenshot sa.
Yes, sir.
Yes.
Sa mga nitan-aw daw sa live, sir, kaya di sila kita sa board, sa whiteboard.
Di sila kita sa whiteboard. Hindi
Walay
gani.
whiteboard, sir.
Gani gi-off man ako ang kuan, gi-off naman ako ang camera. Da sa kita na ako kadali ha, kato ako gi-live ha.
Okay, sir.
Sa kay duha mong guni ka kuan, duha ni ka computer og gigamit na. Let's try daw na og spotlight.